Hello again, into our third session with Sarah Gaunt from SPG Innovation. She'll be talking to us about texture and nutrition via collaborative R&D. So Sarah, over to you.
Yes, thank you for that introduction. So I'm here today from SPG Innovation. As the title says, I'm going to talk to you about some of the projects that we've been doing working with plant proteins, and really focusing on texture and nutrition and how we've worked on this through collaborative R&D and benefits of that, and some of the results. So just a little bit about us. So we are a sustainable nutrition company. We're based in Nottingham in the UK. Our mission really is to meet the trends and nutritional demands of consumers today in the food industry, but without being detrimental to the future of the planet. So looking at food security and environmental health. So making sure that foods and ingredients are healthy and sustainable. So we do this by working, we're a team of food scientists, and we apply that science to solve product development challenges. So where you've got issues that a normal kind of NPD process is not solving and you need that little bit of extra science, we can come in and support. And we work really with brands, manufacturers, and whoever is trying to create that healthier, more sustainable product. So the way we work, we've sort of got 4 pillars of kind of expertise that we can support our customers with. I'm going to talk through this, and then the other flip side of what we do is we do our own R&D, which is what the bulk of this talk is about. So we're talking about that R&D, some of the projects that we've been doing. So these are our 4 pillars. So extrusion expertise. So this is the first one. So we have a pilot scale extruder. This allows us to manufacture snacks, cereals, meat analogues, plant proteins. And because it's sort of a pilot scale, it's not a tiny desktop extruder. It is representative of sort of scaled up manufacture, but it's small enough that you can do the R&D with the kilograms rather than tons of product. You can create those first couple of batches that go to a supermarket or a retailer, and you're not committing to sort of MOQs of 40 tons a year. So we're there to kind of provide that, really the start of the journey when you're looking at extrusion. The work with extrusion and particularly with plant proteins, has led us into sort of this protein consultancy area. So we've done a lot of work over the last 4 or 5 years looking at plant proteins and looking at the functionality and understanding actually what impacts the functionality of proteins, which areas they work best in. Some of the stuff that we've worked on shows that one fiber being protein is not the same as another. So processing, it really impacts things like functionality and how they'll behave. So we work with some of our clients to look at actually which is the best proteins to use for functionality, which is the best proteins to use for nutrition, how we can blend them, how we can create protein-based products. Other areas that we can support with, because we're sort of a food science-led team, we work with our clients who maybe don't have that food science expertise, they don't have a technical team in-house, so we can, rather than them kind of employing someone, they'll work with us on a project-by-project basis so that we can solve those challenges, support the teams. It could be a grant-funded project, it could be sort of anywhere where you need that technical input. And then finally, the last strand of what we do is looking at functional ingredients testing. So actually what we found through a lot of the protein work is that the functionality is really important, and you can't just tell because you've got the same ingredient whether that functionality is the same. You need to kind of test it and understand how it will behave in different environments and different food matrices. And this has proved really useful for ingredients manufacturers to be able to go to their customer and say, actually, it can do X, Y, and Z, but if you use it in this application, this is the killer application, and you can get rid of other ingredients, you can make it last shelf stable for a lot longer, and understanding your ingredients, and that testing has been really interesting to do. So this is just a picture of our facility. As I say, we've got a pilot scale extruder there in the corner. We've got a general food grade facility with a kitchen and food preparation area. We are currently going through SALSA accreditation, so that's really key for sort of the snacks, cereals, plant proteins, because we'll be able to produce small scale batches that can be sold in most retailers and with that quality accreditation. Also got a compression popper for rice cakes and other expanded snacks, and then a general laboratory space for kind of looking at products that are possibly not food grade or co-streams. We do a lot of work in sort of co-streams. So moving on to the project and kind of the main topic of this talk. We've, as I say, we've been working in sort of plant-based proteins for a while now, and we started off this mission trying to think about actually, can we use less refined and more diverse protein sources in some of the plant-based foods? We did a review of the market probably 3 or 4 years ago and looked at all the products that were out on the market in supermarkets, and 80-90% of them were soy, wheat and pea based. So actually, we thought there must be opportunities here to work with different proteins, less refined proteins, more interesting ones, and also looking at combinations of protein crops, so blending those protein crops to deliver more nutrients and better amino acid profiles. And then we got to thinking, actually, that's interesting, but what happens when these products get into the body? So we've just running through a program looking at actually how do these plant-based proteins affect the microbiome and the gut health? And through this work, we also spoke to a lot of protein manufacturers, and starch and fiber side streams were of interest, and can we utilize those? So those were our key challenges, and our approach really with this work was to see if we can move away from some of those protein isolates. Can we use flours or byproducts even, and can we, one of the issues that we were seeing was you were getting soy that was grown in the Americas, shipped to China to be processed, and then brought back to Europe to be included into foods. And can we move away from that by reducing some of the processing, or using possibly more locally grown crops? And how will that improve our health, the health of the planet, and reduce costs, and hopefully increase access to plant-based foods by reducing cost? And also looking at kind of whole plant alternatives and whole food alternatives. So the reasons we were doing this was when we looked at sort of the customer drivers, 48% of consumers were citing health as one of the main reasons to reduce meat and dairy. They were interested in gut health, and so actually understanding the impacts on health and understanding gut health in particular with plant-based foods was a real that we thought was a good idea. A lot of consumers are looking to lower their carbon footprint. Climate conscious eating is a strong motivator. But actually, if you look at the data, price and taste are still the biggest obstacles to choosing plant-based alternatives. And then probably in the last 12 months, really, you throw into the mix ultra-processed food and possibly plant-based foods falling on the wrong side of that debate. It's actually quite interesting. Can we do something more with whole foods and more with kind of less processed ingredients? So some of the technical challenges that we were looking at then to start working with this is really achieving that meat-like texture. So plant proteins lack that fibrous structure of animal protein. We can use extrusion to create some of that, but quite often you'll need binders and hydrocolloids to kind of mimic the juiciness and the bite. Flavors and off notes, again, are quite a big issue with plant-based proteins, and can we do some flavor development? But then a lot of flavors are really made for working with different interactions differently with plant-based proteins than they do with fats and seasonings. Nutrition was one of the key areas that we really wanted to focus on, and actually often plant-based proteins don't have all the essential amino acids. So can we blend them? Can we fortify them? Can we look at other ways? And can we understand actually what happens to some of these during processing? So that was a key area that we're looking at. And the functionality is an interesting one, because plants do change And I mentioned that earlier, they will change depending on how you extract them. The functionality, they'll change depending on the variability within a year. So actually understanding how that impacts processing and downstream processing was really important to us. So the approach that we've taken, we've kind of had a project running for a couple of years now, through various different ways. A couple of them have been funded by Innovate UK and BBSRC. We wanted to create textured vegetable proteins mainly using our extruder, using a diverse range of protein sources, and we wanted to understand the impact on the body. So, as I mentioned, we've got in-house expertise to look at protein ingredients, to look at extrusion, and understand how you use proteins in different food applications. But we really needed that expertise in the digestibility of the plant proteins and what happens when it goes into the body, into the gut. So we started working with the University of Leeds, and they supported us with the digestibility. They're supporting us at the moment with a gut model, which is the MyGut model. And that's been really, really useful. And that's kind of the topic of what I'm going to talk to you about. So we started kind of assessing all the protein sources that are out there, and this included looking at different flours, co-products, waste streams, understanding where we could find some high quality proteins that we could use as feedstocks, and not just protein isolates, but we wanted to look at less refined proteins. And the reason for doing this was not just the sustainability, but also to look at actually the inclusion of things like fiber. Obviously, we understand that would be good for health, but also some of the oils. So some of the work we did looked at oilseed meal, brewer spent grains, and they were identified as really interesting materials for not just functionality, but the oilseed cakes have still got some oils left in there, which gives them actually a much nicer kind of smoother mouthfeel when you create textured vegetable proteins. Some of the fiber in there seems to retain the structure better. So actually the functionality is really interesting as well as the protein. So we looked at the protein quality, understood the limiting amino acids in samples, and then also looked at anti-nutritional factors and assessed kind of what happened during extrusion. We found that extrusion could reduce some of their content, which was really, really good and helpful. So this is some of the extrusion that we carried out. So we took that list of proteins that we'd identified, and a lot of them were extruded in isolation, and then in blends to understand actually how well they texturized, what their functionality was, as well as things like the amino acid and the digestibility. Key variables seems to be like that accessibility to that functional protein to be able to create those bonds and create those textures and that fibers. And so we did some work looking at pre-processing trials to understand actually can we improve that accessibility to the proteins before the extrusion, and can we treat the protein powders before they go into the extruder. We've also done some work looking at alternative methods of texturization without the extruder. And the aim of this was actually, can we use more whole ingredients or ingredients where we know that the fiber in particular is interfering with the creation of texture through sort of the traditional extruding route. So we've created some products, some tofu style products using whole ingredients, and using sort of more locally grown crops and beans and pulses rather than soy. So we've created a lot of samples here, and then the next steps, which is where we are currently, is actually looking at that gut health. So as we know, many consumers are kind of trying to reduce their meat consumption, and they're including plant-based meals in their weekly routine. But actually, when we started looking at the data, there's not a robust data source that shows actually what the impacts are of eating more textured vegetable proteins, and how actually people focus on protein as that key nutrient, but are there other things within that plant-based product, such as fiber, that could be beneficial, but equally are some of these plant-based foods higher in salts and sugars and fats potentially that could be causing issues. So we wanted to do some trials and look at that repeated consumption of higher protein products from a plant-based source. And this was all this is currently being carried out at the University of Leeds. So they've initially assessed the digestibility, and we've chosen some products, and then we've put them into the My Gut model. So this is kind of an outline of the work that we've done and the work that we're continuing to do. So we've developed those protein ingredients. So we've identified interesting proteins, and we've developed some protein ingredients. We then looked at the impact of processing on amino acids. So we now know that actually through extrusion, some of those amino acids are getting damaged, and some of them are okay, some of them are not being damaged through that processing, but understanding how much they're being damaged and what's happening to anti-nutritional factors in particular, and whether they are reducing or increasing. So we did find that actually through extrusion, on the whole, anti-nutritional factors were being decreased. This meant that we could then optimize those ingredients that we were making for nutrition and functionality. So creating the best textures within textured vegetable proteins for use in all sorts of different foods, but also with a complete amino acid profile that we know is surviving through the extruder, and optimal digestibility. So this is some of the work that a little picture there of some of the work that we've done on the alternative texturization methods, and looking at actually creating some products with whole foods with additional fiber and all sorts of good stuff in there. So next now, and this is where we're up to at the moment, is looking at the impacts on the microgut and going through My Gut model, and understanding actually those optimized ingredients, which are good, functionally good, and we think their digestibility is good, actually, and they've got that fiber that you're not necessarily getting from meat. How is that impacting that microbiota, and is that a positive thing? So that we're just sort of waiting on those results over the next sort of 6 months. We'll get some results out of that, and we're developing sort of use casing for protein ingredients as well. So I guess for a small company such as ourselves, being able to work in this model and being able to do collaborative R&D has been really useful, because it's given us some really good impacts. So being able to demonstrate actually the importance of blending proteins to achieve high quality protein ingredients, identifying ways to texturize less refined ingredients, so not just protein isolates, and have those additional benefits such as fiber. It's enabled us to create databases of how processing can impact functionality, quality, health of ingredients, and start to generate data on that impact on the gut microbiome. It's also working with likes of the team at Leeds has enabled research papers to be published, which really enhances our credibility in this space, and also adds to that knowledge out there, because when we started looking at sort of the impacts on gut microbiome, it was really limited, and we were surprised how little data there was out there. So actually now to be able to start putting some of our own papers out there is really, really brilliant news. And we've launched products and services. So the work that we do on our own R&D streams kind of has a few, it benefits our customers when they come to us with problems, but it also means that we can develop products and ingredients that we can look to license, we can look to add to our services, we can look to actually launch ingredients. So one of the ingredients that we launched through this project was a hemp TVP, which was sort of a mince-like texture, and because of the additional fiber and the additional oil, it had a really good mouthfeel, it had a really good texture. So those are some of the benefits really with working with collaboration. So we're, I guess, really keen to develop more collaborations with industry. We worked a lot with different partners and different universities to progress our R&D to date. Funding from the likes of Innovate UK has been really valuable, and it's supported our work, and it's enabled us to be able to access partners like the expertise at the University of Leeds, which would be beyond an SME of our size to be able to access. So that sort of thing has been really useful. So I guess going forward, we're really keen to talk to people who are looking to valorize waste streams, looking at plant-based sector, looking at proteins, fibers, starches, food manufacturers or food service looking to move away from soy and widen out their protein sources. We've got some product prototypes and we've got some really good ideas in that space. And also plant-based brands and food brands with problems. As an R&D hub, we're really aiming to provide innovative solutions. So thank you for listening. This is my contact details. If anybody wants to contact me, you can either contact me through the app or through these details here, or just nip onto our website or LinkedIn. But thank you very much for listening, and happy to take your questions.
Thanks, really interesting stuff there. Yeah, I'm going to go straight into the questions. Absolutely. So I think the big one at the moment is, everybody's talking about UPFs, ultra
Mm,
processed foods, and hyperpalatability as well. This idea of the
mm.
texture of things. So I think it's really important that you're working on that. What kind of impact has that had on you, that debate, particularly, and, through your work with fibre, are you able to sort of address that in a way that some of the sector hasn't been able to, maybe?
Mm. I think some of the ingredients that we've produced, some of the textured vegetable proteins that we're producing, have got more fibre in them than you would normally get. Obviously, by going through an extruder, you kind of falling foul of that UPF. Depends which definition you use of UPF, because it's not that simple, but it kind of starts creating a UPF anyway. So actually looking at other ways of whether we can use whole foods to create products that are a little bit more interesting than just vegetables has been something we've been working on. But I think the extrusion side of things, if you can create good textured vegetable proteins that possibly don't need those binders, and they've got all the additional ingredients. So the hemp oilseed cake ingredient that we talk about is, it's actually got residual oil still in there from the pressing. So actually that mouth feel is really quite, it's kind of almost meaty, and the texture holds up really well. So actually you're using less binders, you're using less things to emulsifiers to create that mouthfeel. So actually, if we can go back to some of the basics and look at some of the ingredients, we can possibly start reducing those ingredients that you need in products, which reduces your list and possibly gets you away from the consumer fear of UPFs. I think plant-based has kind of been lumped into the wrong side of UPFs, possibly unfairly, I think, if you look at some of the data. And
Yeah.
I think if you look at the health benefits of actually eating more plants and less meat, it sort of outweighs any of the negatives that might have been found. It's really tricky, I think, that the
It
UPF
is. It
debate.
definitely is. Yeah. So
Mm,
I'm interested because you've talked about sort of
mhm,
good function, good texture, good health
mhm.
benefits. All of these things which are really important. But you also mentioned the other critical one, which is taste, right?
Yeah.
Again and again, consumers say, yeah, but if it doesn't taste right,
Mm.
no dice. So are you working with others on that as well? Have you sort of worked with people around that kind of taste and flavor element?
Yeah, yeah, definitely. Because I mean, I think we're all come from that kind of taste is king, and if you might get someone to buy something once, but if it doesn't taste
Mm,
good, people are not going to buy it again, regardless of the other attributes it might have. So that's always kind of fore of our minds when we're developing ingredients or foods, is actually making sure that those that it tastes good and that I would want to eat it. So we work with kind of development chefs, we work with people in flavors to try and make sure that what we do creates good tasting products, because it's not gonna, I mean, people are not going to buy it more than once if it tastes bad.
yeah, yeah, absolutely. And just one last question, if I may.
Mhm.
I was really interested in this idea of using more sort of local crops, perhaps at the UK scale or whatever. But
Yeah.
how big an opportunity do you think there is in kind of using those those perhaps less used crops that are here and available in the UK in terms of both their environmental and their sort of health benefits in a sort of circular economy sort of a way.
Yeah, it's an interesting one because I think we started out in this whole journey being a little bit naive, thinking we're going to create local protein ingredients from local crops in a local market, and actually, it's very difficult to find a good supply of uh, locally grown protein crops that are BRC, or they've got the right
Mm.
accreditation so that you can then sell on to the right places. So it's actually quite difficult, and you've got kind of the powerhouses of the likes of Canada producing all sorts of different crops. So actually, I think it's really important that we do support local crops. Interesting thing is that consumers say they want locality, but actually when it comes to buying, they don't always follow through with buying local crops. But I think there's an opportunity for us to um, think less about scale and more about locality, and actually, and I think we're going to have to do this if we're going to if we're going to start moving more climate positive, and actually start using things that are in season, grown locally, not flown around the world, not monocropping. But it's difficult, and we're still not set up for it in the UK. We might be growing certain amounts of stuff, but we're not set up to process a lot of them, and we're not set up to do things like extrude massive amounts of them. So unless we switch our food system to a more locally smaller grown, it's difficult.
Yeah, yeah. Well, there's a call to action for the for the day.
Yeah,
Let's do
sorry.
more of that. Excellent. Well, listen, Sarah, thank you so much for joining us here today and for giving us that really interesting presentation. You've all seen that Sarah and her team are deeply open to collaboration, so do reach out to her through the options that are there or elsewhere and on this platform. Sarah, thank you again, and yeah, we'll be back with our final speaker of this session momentarily.
Thank you.